Okay. All right. I'd like to think I could make that a little better, but we'll see. All right, today's agenda. We will go through project 3. I'll recap a little bit on exceptions. We'll finish up exceptions, and we'll start off on modules. So over the weekend, I shot a video. I sent an announcement about project 3. If you didn't get to see it, I go through some details here. I did mention to some folks that we are going to be calling out to Spotify for this. As I was scoping out the project and working on it, I realized there's probably a little too much to do for project 3, so that's actually going to be bumped into project 4. But it's like it's one big project. Project 3, you're going to need to do project 3 and do project 4. So what are you doing in project 3? In project 3, we need to build the core classes that we need to get tracks, albums, and artists from Spotify. So to that degree, I went out and sort of investigated what Spotify's API looks like and gave you the basic classes that are used there. So the first part of this is going to be similar to what you did in the assignment. You're going to take this UML and you're going to create the classes. Some of the more chunky classes I've provided for you, but you got to write the code in here. You should follow the instructions, but worst case scenario, if you just want to do this based on the unit tests, just come over here and it will tell you. Assertion error, track class does not seem to exist. Okay, so you just have to know the right place to put this. Class track. Represents the song. And then test. Okay, next one. Class album doesn't exist. There's track. There's album. I'll cut right to the chase here. Artist. Okay, so like those 3 lines of code gets you 12 points. Pretty simple. Fine, move on to the next step. Track does not have expected base class serialized mixin. So I'll leave that to you to figure out what that means. You should know what a base class is, you should know what a mixin is, and how to sort of appropriately decorate your classes so you can pass that unit test. Once you finish part 1, and you get all green on here, part 2, you'll cut and paste your code over here. So step 0 is copy your code in here. I have a unit test to make sure you copied it properly. And then you're going to write the unit tests for those 3 classes. So unit test was that end of chapter 10, that thing that I said is very important. You're going to be writing the unit tests for the classes you wrote. And then I'll be writing unit tests for the classes you wrote and the tests that you wrote to make sure they go through the work. Finally, after you write your unit test, you'll do some more changes. You'll add some more methods, something called serialization, and you'll enhance your class, you'll enhance your tests. At that point, we're ready to use this stuff with Spotify. I just took that out of this project because I thought it was a little bit too much to do in one go. Any questions on this for project 3? Okay. So this is going to be due Wednesday, 27th November. So right before we leave for vacation. I don't want this to bleed over that long weekend. I'd rather you prioritize project 4 and or study. So this is due before you leave. I will announce I'll probably hold extended office hours later this week and next week for anybody who wants to come in and do it. I think a lot of people who are working on project 2 felt the benefits of coming to office hours. We got through damn near all 6 of those challenges. Most people came to office hours. So I encourage you to come to mine or the TAs. Okay. Any questions on the project? Okay, so on to business. Hopefully this works this time. I just love this movie. I really just want to play it so I can play the movie.
This is great. Oh, beautiful. God. Where do you think you're going? Nobody's leaving. Nobody's walking out on this fun, old-fashioned family Christmas. No, we're all in this together. This is a full-blown 4-alarm holiday emergency here. We're gonna press on, and we're gonna have the happiest Christmas since Bing Crosby tap danced with Danny fucking Kaye. And when Santa squeezes his fat white ass down that chimney tonight, he's gonna find the jolliest bunch of assholes this side of the nut house. You're goofy. Don't piss me off, Art.
Clark, it's over.
Not according to Santa's watch, it isn't.
Now, come on, son.
Stay out of this, Dad.
Clark, I think it's best if everyone just goes home before things get worse.
Worse? How could they get any worse? Take a look around you, Ellen. We're at the threshold of hell.
Again, mostly I just love the movie. I think it's great. My best friend, well, two of my best friends, Jay and Kimmy, we met in college because of this movie. We were both watching it in October for some strange reason. My second year at university. So, anyways, what does that have to do with any of this? Again, Clark says this at the end. We're on the threshold of hell. How could things get any worse? And honestly, there's this concept of being a defensive programmer. This is one of those, there's programmers and then there's good programmers. The good programmers, they know exactly what their code's going to do, and they know exactly where their code's going to screw up, and you try to recover from that. So we looked a little bit at that last time. We'll look at it more detail today. But to me, people ask me when I knew I loved computer science, when I wanted to do that. Like when I had this moment, when I just like could sort of visualize everything that possibly could go wrong, and then you start coding for that, you realize your program can stay up and it can run for days, weeks, months, years without issues, and you're like, yeah, I guess I know what I'm doing. So this concept of exceptions, it's not really magic. There is a class that exists in Python called exception. So you can look up the exception class, and most of these subclasses, these derived classes, they all have the suffix error. We probably encountered that. Most of the time when we're running our IDE and we get an exception at the bottom and it says problem on line 32, whatever, it was one of these errors that got printed out. So we'll look today at creating our own to see why that might be useful. I put together a bunch of slides last lecture. This is an amalgamation of all of those slides into one. As far as I can figure, this is everything you need to know about the syntax of a try except, try catch, any of that madness. So to date, we've been writing all of our code, either in the global scope with no indentation, or inside our main, or inside a function, or inside a method inside a function, right? So the important thing is we indent. So all the code that we would have written like today, we just indent it and say, okay, time begins there. To anticipate the code that might blow up, we need to know, okay, is it going to be a value error or a type error? If that's the case, then in this block here, I can try to recover from that, whatever that means, right? It might mean the user gave me the letter A, so I'm going to reset it to the value 93. Or they gave me the letter C, and I'm going to reset it to the value 67, something like that. Make my code more resistant. So if the way I recover from exceptions is the same, I just group them together like this in parentheses with a comma. If there's only one particular way to handle this exception, I just call it out by itself. And then finally, there's this catch-all bucket, which again, debatable if that's a good practice or not. Some argue it is because your code is going to survive any sort of error or exception that occurs here, but bad because you, as the programmer, weren't able to anticipate what that problem might be. But the point is, after the flow of control exits this, my program survives. I'll print out this statement here, my program just won't blow up. So this is what we learned last time. There's one last part to this journey, the finally block. So all of this code here, in some cases, I always want to do something, whether there was a problem or whether there wasn't a problem. When we were learning files and we were using that with Context Manager, if you go in and you look at the code for open file, this is literally what you will see. And then down here in the finally block, you will see file.close. Right? Remember, that's very important. It has to happen whether you successfully read from your file or there was a failure. You always have to close it. So that's where you would see that. So we'll take a quick peek at that. So hopefully we can all digest this program at this point. But I want you to notice a couple of things here. I have multiple try blocks here. So I have a try block out here at my global scope. And what am I doing? I'm initializing some variables here. And then I have a while loop. I have another try block. And the reason why I have another try block is I want to be able to continue asking the user to do something over and over and over again, kind of no matter what. But once I get out of that, something bad still might happen. Let's walk through some of this code. So we'll start off, we'll initialize some of these variables here. Nothing new from what we've done before. Now, I'm going to ask for a grade. I'll be sort of a naive user. I'm going to enter in the letter A. I think I want letter grades, right? So I come in here, and I'm going to try on line 15 to convert that to an integer. So I get a value error. So that falls into my except block here. Print out to the screen, not processing grade A. But look where the flow of control went next. It went into this finally block, right? It went into this finally block so that I could keep track of how many attempts the user made. So maybe when I was writing this program, I sort of anticipated people might enter in the letter A or numbers. Maybe I want to go back later and clean up my code and allow people to do that. I don't know. But because I caught that, right, my flow of execution stays inside that while loop. So now I'm waiting for another grade. Maybe I'll make that same mistake. I'll put a B in. So the user is going to get that message, not processing grade B. Okay, maybe the user gets the hint at that point, says, oh, I'm supposed to put numbers in. So the user enters in a number, 93. Now they have a B. Let's put the 80 in. And finally, let's break out of my loop. So I'm not going to enter in anything. I'm going to enter in that empty string. So I break out of my loop and watch where the flow of control goes. Goes into my finally block, right? So I can still keep track of the number of attempts that user made. There were no problems on that outer loop, so all these accepts were passed, and I fell into the finally block here. So you don't fall into finally if there was just an error. You always go into the finally block. So here I can print out a nice message. 2 grades with 5 attempts with an average of 86.5. If I go in, and I think we had this problem last time, where if I don't enter any grades, let's try that scenario. I'm going to do this calculation on line 24. Notice I'm outside of that inner try catch block. But here, I'm going to do division by 0, kind of intentionally. So I fall into this outer except block. and I recover. You know, app and crappy recovery, but app right now due to division by 0. I reset the average, I reset the grades, and I print out a nice message. So you can see here, it's possible to use try catch to allow your program to continue when you want it to continue and not continue when you don't want it to continue, right? All right, so these links are obviously in the slides. If you want to step through it yourself, please do so. So we looked at catching exceptions first because we don't trust. We shouldn't trust in programming. We don't trust libraries that we're using. We don't trust the user. So we want to be sort of defensive and protectionist, right? That doesn't mean we can't throw exceptions or raise exceptions ourselves. So here's a pretty classic example. It's not a syntax problem, right? But it is sort of a semantic error. Let's say I was building a banking app, right? And somebody wants to withdraw money. Well, I shouldn't allow someone to withdraw more money than is in their account. So I have a function here, withdraw, that takes an amount and a balance. And so the new balance becomes the balance minus the amount. I can do this. I can be proactive in my program and say, raise value error, insufficient funds. So before I try to deduct this negative bank account, I can say, hey, there's a problem, right? This is something very common you want to do in banking. You don't want someone to withdraw money and you have a negative balance left. The bank would lose money, right? So this way, when I go to call that function, right, I can catch that exception, right? So not only can I attempt to do that activity, I can catch it and I can recover. So what does that look like? This is pretty much the same code we just looked at. Here's this withdraw function. I'm just going to do something a little groovy down here in my main. Down here in my main, I'm going to set the initial balance to 150, and then I'm going to randomly, using random, try to take money out of this account. So let's step through it and see what happens when I run out of money. So the program starts off, it kind of just puts that function on the stack. Nothing happens here. I go into my main block. I set my balance to 150. I say my starting balance is 150. I call random, and random, let's see, amount is 50. So it's going to try to take out 50 bucks. So withdraw 50 bucks from my account that has 150. Everything's cool. No problem here. All right, back into my loop. Let me get another random amount. I'm going to try to get 98. I have 100 bucks in my account. That should work. So I go in here, 98 less than 100. Yes. Cool. So my balance has 2 bucks in it. All right, let's get another random number. 54. Should that succeed? No. I only have 2 bucks in my account. But let's try it anyways. I'm going to try to withdraw. I'm being proactive here as the program. I'm raising a value error. Nope, insufficient funds. Okay, but look how smart I was as a programmer. I put this in a try catch block, right? So I'll happily let that user try again. They're going to try to take out 3 bucks. Oh, that should fail too. They're going to try to take out 9 bucks. That fails. They're going to try to take out 6, or how much is this? Let's see. 4. Nope. They're trying to take out 2 bucks. Cool. That should work because I have 2 bucks in my account. All right, I have 2 bucks in my account. Balance is 0. My program leaves successfully. So you can see that's a program that recovered from errors. I raised some errors, right? In an attempt to sort of be proactive. Now, the last thing to call to your attention, and it's not totally necessary, but if I wanted to have my own exception. I could say def insufficient error. And that has to extend exception. And I'm going to give it a constructor. Which takes self. It's going to take some message. And I'm going to take some number called deficit. Since I have a parent class, I'm going to call my parent class, which takes self. And those exceptions, you always see a string, so there's that message. And now I'm going to create some local variable called deficit equals deficit. Now here, instead of raising a value error, I can raise an insufficient error. And I can put in some extra information, whatever that deficit was. So down here where I used to catch value, I'll catch insufficient error. And let's cut right to the chase on that. And I will try to make that fail immediately. Let's try to withdraw $160. So I come right into my function. I'm going to try to withdraw 160 from 150. Nope, I'm going to raise an insufficient error exception. And I fall into this block, and I can print it out. Uh-oh. Catching classes that do not inherit from base exception is not allowed. Let's see. Oops. Insufficient error takes one positional argument, but two were given. Self-message deficit, that was good. Anybody see what I'm doing wrong in there? If not, we'll try to fix it here. Don't you love our indentation? This is why I hate this part of Python. You know what? I'm going to have to get back to that. I don't know why this doesn't see exception here. Catching classes that do not inherit from base exception is not allowed. Maybe this is a Python tutor thing. You know what would help here? I made it a class. There we go. Okay. Hopefully we're good now. Let's see. Try to withdraw 160 from 150. I got an error. Construct my class. And I fall into this block. Insufficient error. And I can print it out. Insufficient funds cannot withdraw 160 bucks. So, after all that, that's how you create your own exceptions. Just create a class, subclass, exception. All right. That's it for chapter 11. So let's get on to chapter 12. Modules. There is not much to this chapter because y'all have been doing this. So the general concept, let's go back to that same example here. I have a function, and perhaps I want to use that over and over again. So the idea is I could take just that one function, and I'm going to move it into its own file, bank.py. And then if I was building a banking app, and I had one app that was going to be used at the drive-through, and one app that was going to be used when somebody walked up to a teller, I can import that same function and use it in the drive-through, and then use it at the teller's computer, right? I'm not telling you anything new here. Y'all have seen this when we tried to use map, when we tried to use random, when we tried to use collection, a whole bunch of other ones. The basic syntax that we know, import name of the module, right? And so then I can just say the name of the module and then a function that I knew existed there. You can also do this. This is new in this chapter. You don't have to say import random, import math, import collections. If you want to, you could say import random, comma math. And then, yeah, I guess here I'm just calling a math function and a random function. This weird sort of Python way of speaking. From random import rand int. Anybody remember what that did? Rand int generates a random integer. Yes, that's a fair statement. What this does is this imports just that one function. So if you went inside random, there'd be like hundreds of functions. If I just want that one function, that pulls in that one function. So I no longer have to say random.randint. I can just say randint directly. I can import multiple functions from inside here. So there's actually a function called random in the random module that generates a random float. So I could say from random, import randint in random. And then I could just say randint in random to generate those. And just another example for math. The last thing that's introduced in this chapter, and some of you have seen me do this on the assignments and stuff already. If you don't like typing out the name of that method or whatever, give it its own name. So here, you'll notice in some of the times, like I write code, I get sick of typing rand int. It's just a lot to write. So I can say from random import randint as RI. So I'm sort of telling the interpreter, hey, rename this thing RI. And so now I can just say RI. And then here I can say import randint as RI, import random as R. Now I can just call it R. Now we have to be careful with that because like this could get really confusing really fast. Number one, I guess warning number one, all your imports should always be at the top. Why? So people have a shot of sort of finding these errors later on. If you kind of like intersperse these in your code, people might look at that real quick and think it's a for loop. Like it's real quick. Oh, I don't know what that is. Right? But also when we rename stuff like that, so like where this one can go south really fast. Let's see if I have this somewhere here. Yeah. So here, let me create some file. File.txt. ABCD, whatever. If I have this code here, like we very often do this for file. We say with open file.txt, that's F. Well, I might have been lazy and said, hey, I'm going to be calling the float absolute value function a lot. I just want to rename it F. So like when I run this code, for one moment in time here, right? Print F printed out that this was a function. That's cool. When I called the function F, trying to get the absolute value of -20, it gave me 20. That's cool. Here, I opened up this file. This line right here, where just a second ago, this was the fabs function. Well, this is all jacked up now because this thinks this is a file. So we want to be very careful and cognizant of what we name the things we import. So now here, you know, I should get something that's more reasonable. So printf, that's a function. Calling that function gave me something reasonable, 20. Oh, look, I called it a second time. It's still fabs. And then now here I'm using F as a file. And I don't know, I guess this is the garbage that I pasted in that file. Okay. The last thing to look at, and this is very important. It's not covered in the book. I might ask you questions about this. How can you figure out what the Python interpreter itself is doing? So this is that stuff, again, that's a little bit hardcore computer science stuff. Probably don't need it so much just for regular coding around. But how is the Python interpreter importing those modules, right? So there's a bunch of modules. There's the built-in modules that have things like string, integer, list, all that sort of stuff. Well, the good thing is Python will show you. So there's a module called sys, which we've used before, and it has an attribute path, which will tell you where on your computer system it's looking for particular files. And so hopefully I can share this up here. Sorry, I don't know if I can make it much bigger than that, but so if I go to my command line where I have Python installed, so I'll start my interpreter, import sys, print sys.path. So this gave me back a list. I know that by the square bracket. The first place Python's going to look for stuff is the empty string or the current directory. So like when we were screwing around in EdStem and we had the images directory and stuff, well, it starts just like in that root directory looking for .py files. Then it's going to say, right, I'm going to look here. Library developer, command line tool, blah, 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 blah. So if I go onto my machine, and you'll know a Mac, this is just like the file browser like on Windows, right? I could follow that path, which is roughly library, developer, command line tools, library, Python. I'm using version 3.9. I don't know if you can see in here, but there's a whole bunch of .py files. So again, Python is not magic. You're just calling functions that other people wrote in other files. So I don't know, if I went in here somewhere, that's something that's sort of reasonable, I guess, to look at. io.py. IO is just input output. Now again, a little bit of an eye chart here, but you should be able to open up any Python file. You should be able to open up any Python file and make sense of some of the words in here, like this. From _IO import. So import all these things. We just talked about that. Ooh, there's a class in here called class IO base, right? Ooh, there's a try catch block here. Try except, right? So the whole point of this class where you're supposed to lead this journey is you should be able to open up any of these files and kind of make heads or tails of it. Be like, yep, that's a method or a function or a class or a try catch block, right? And again, depending on how deep you want to go here, if you're going to be a hardcore developer, awesome. Go into these things, see what other developers have written in the past, you know, learn some tricks and tips. But it's all there for you to explore. All right. So back to this. We have, let's see, maybe 10 minutes worth of module work to look at. We're going to knock that out on Wednesday. But first we'll do quiz 10. Thursday in lab will be quiz 11. Reminder, assignment 10 is due at 11 p.m. There was some issue with it, which I'll look into afterwards here. Friday, quiz 12 on modules. If you're going to be out of town by Friday, let me know. I'll let you take it early. Tuesday, next Tuesday, assignment 11 and assignment 12 will be due. I should have those done today. Those are going to be like a 1-minute exercise. It's going to be like, write me a block with a try catch, write an exception. Yeah. I don't know. Whatever Tuesday is. The assignments will be Tuesday. I like to give you 24 hours notice and I haven't released them yet. So whatever Tuesday is. Wednesday, project 3 is due before we take off. And that's when a homework 11 and 12 are due as well. So I got plenty of time to get that done. As I mentioned in the beginning of the class, we're coming to the end here. Next Monday, we'll do exam prep for 10, 11, and 12. When we get back from break on the 2nd of December, we'll do final exam prep. Wednesday, December 4th, exam on 10, 11, 12. It'll be short. It'll be quick. Thursday, December 5th, project 4 will be due. I should have that out in a day or two. Yeah. Yeah, I will pepper in code jams throughout next week. And then when we get back from Thanksgiving break, for sure. And then our final exam is Monday, 9th of December. So see at the end, folks. One more class on lectures. That's it. And it's just exam prep. I have office hours now till 5. Anybody wants to work on anything, let me know.
Take